I gotta understand what's going on
Yeah.
inside the robot. You
So
find the best and invent the rest.
so the basics on every robot's pretty much the same. You're gonna need the RSL. That's just first rules for safety.
Right.
It just signals whether or not there's something wrong with your robot or something.
I noticed we have one on our robot. Does it turn off if something's wrong?
Yeah, it should.
Okay.
Um, to actually connect to the field, you're gonna need a router,
Uh-huh.
which is just connects directly to the RoboRIO.
Right.
The main thing you have to worry about on an electrical system is the breaker. If anything goes wrong, anything starts smoking, anything explodes, catches fire,
Uh-huh. Uh-huh.
you'll want to
You
press that
just
red
turn it
button.
off.
Yep.
Yeah, big red button. We've had to do that a lot.
All right.
And this is just a
And that cuts all electricity flowing through the robot, right?
yep.
I know how to power cycle.
Power cycle. What do you mean?
Just turn off the robot, then turn it back on. And I don't know why he does it. I'm pretty sure it's to push code, but whatever.
Oh yeah. Well, obviously, power source is going to be a battery.
Oh,
The batteries we have are rated for 12 volt,
yeah.
but when fully charged, our batteries go about to 13.6 volts.
Right.
And in electricity, there's various characteristics like voltage, current, resistance. Voltage
Right.
is basically the force in which the electrons are hitting each other.
Mm-hmm.
All of our batteries have about 18 amp hours. For current is measured in amperage. The unit is amps. And current, in terms of electricity, is basically the rate in which electrons flow. And a lot of classes will actually compare it to like water systems and stuff. So like the speed in which the water is moving through like a pipe or something is kind of like current in electrical wires. Amp hours is a unit of power, and it basically tells you how long at a certain current draw your battery will last. All of our batteries are rated for 18 amp hours, and then for like example, a AAA battery will have 1 amp total. For our robot, usually the batteries will last probably around 6 minutes, but after each match, we like to charge it up just in case, because these batteries do wear out eventually.
Is that why terabytes has like 50 of them?
Exactly. So the more times you recharge it and draw power from it, the higher what's called internal resistance becomes. Resistance is
It
going back.
just makes it harder for it to store energy, right? Or
Yeah. So going back to like water and stuff, resistance is basically like a check valve. Resists flow in water. So like resistance in terms of electricity, it resists the current, which means the electrons quote unquote flow slower. And once that resistance gets high enough, your battery just dies. You don't want that happening in the middle of a match.
is there anything that can cause the battery to explode?
Yes, it's very spontaneous when it does explode, but general rules is you don't want to short the two outputs to each other. Not only will that cause like a big spark because the current will be so high, but it changes the actual chemistry within the battery and could cause it to explode.
Interesting.
If
Okay.
Good to know.
if you
Yeah.
yeah, if you don't use the
So
right charger, it can also explode.
so you said the way not to connect it, that would be like taking the red wire and clipping it on to where the black wire comes out of,
Yeah,
basically,
that'll be
and
shorting
then
it.
putting the.
Yeah.
Okay. All right, we got to make sure that nobody does that.
Oh yeah.
Or does it on purpose.
Whenever messing with the battery and or creating a circuit with it, always wear safety glasses and thick insulated gloves because that can kill you.
Yes, sir.
Probably the most dangerous part of the robot.
So, how should we react if someone is like messing with the batteries in ways they shouldn't?
If they're messing the battery in a
Right.
way they
Yes.
shouldn't be, just stop them immediately. Tell them what they're doing wrong, and if I'm not there, just try and find me so I can resolve it.
All right.
Obviously, when to actually handle the robot, you had to fill out that safety quiz. or whatever.
Right.
Yeah.
I was thinking about making a electrical safety quiz,
Yeah, there should be like a whole separate quiz for that.
because I don't know. In my opinion, electricity is probably the most dangerous part of the robot.
No, definitely.
Just because,
Definitely, yeah. Here's the thing. Here's the thing.
yeah,
If you get your hand caught in a gear
mm,
of the robot, sure your hand might be messed up or it might be broken or something like that.
mm,
If you pump yourself full of electricity, it's
It
not gonna
feels good.
matter. It's not gonna matter if your hand is messed up or not, bro.
yeah,
That's
Have you
not what
ever?
you'd be
Wait,
concerned
no,
about.
no. You know, if you touch that metal plate with the light switch is on,
mm,
if you ever like hold like two fingers on it, you can feel the electricity coursing through your body.
I don't like that. That doesn't sound very smart.
can't recommend doing that.
I've done it before, and I was like, "Ooh, that feels pretty interesting."
Usually in like classes and stuff, they just want to introduce what it feels like to being shocked or whatever. They usually just take a 9-volt battery and touch it on your tongue. Don't shock yourself. Going back to the charger thing, if you don't use the right charger on the right type of battery, 99% of the time it'll just destroy the capacity of the battery, make it not last as long. But that 1% of the time can lead to it leaking acid, exploding, catching on fire, stuff like that. And these different types of batteries, they're made up differently with different chemicals and stuff. And these different chargers will actually output a varying electric wave in order to charge them. Amp hours are different than amps. Amp hours is a measurement of power, and amperage is the measurement of current. So, you have any other questions?
So we should avoid using a phone charger to charge the batteries?
Yes. Yeah, you do not want to use a phone charger on these. The next part of one of the main components that goes on the robot is what's called a PDP. It stands for Power Distribution Panel. Right, so basically the battery hookups directly to these two terminals underneath this cover right here,
Okay.
and it regulates all the voltage and current for all the motors and stuff you want to add. Because if you just hook up like a motor directly to the battery, there's pretty much nothing limiting the current. It'll just catch on fire, right?
The
Yeah.
what is it called? The clicky button that stops the electricity flow. Called
The breaker.
the breaker. Yeah, that goes between the battery and PDP, right?
Exactly. So it goes in
Okay.
between the positive side of the circuit, and in each of these slots, there's different their own separate breakers for lower current. I think on our robot, the ones up here are rated for 30 amps, and the ones down here are rated for 20 amps. So that's like in case a motor just breaks and short circuits, it doesn't destroy the whole circuit. It just pops the breaker. You can take it out and then reset it.
Oh, you mean like how when the robot, not when the robot,
I'll be right
when
back.
one of our motors starts to
Yeah,
PDP, very important. Has breakers to stop it from destroying itself.
exactly.
Yes, yes, yes.
Now on our robot, we use what's called a CAN bus, which basically it's a messaging system between each of the motors, so that the code can actually control them. So that networking system essentially gets terminated right here on the PDP, and this LED is an indicator light whether it's working or not. And then near the bottom of the PDP, we have another set of, I think, 12-volt outputs for specific stuff that don't really need to go into. This side's 20 amp breaker, this side's 10 amp breaker. So the PDP takes in 4-gauge wire. That's just a size of wire that's meant to properly fit into these terminals. They're actually numbered right here, the terminals that you can just plug stuff into. These black terminals are just the grounding for the circuits.
Right. Interesting. Very important.
Yeah. So this basically is the main thing that regulates the circuits on the robot.
Hmm.
The RoboRIO, this is the brains of the robot. This is where all the processes are happening. This is where all the code's going to be loaded to.
Right.
So all of these ports right here are what's called PWM. It stands for pulse width modulation. Basically, you can hook up your smaller motors, sensors, stuff like that, and you can regulate the voltage that's going to them to change the properties that you have. However, since we used CAN, we avoid a lot of messy wires because with PWM, you have to connect each individual thing to each one of these pins right here, which can, it just adds a bunch of wires to it. It makes it messy and it's just not as reliable. This SPI slot right here, this is where our gyro is. So this is what's called an SPI slot. This is where we put a sensor, which we call a gyro, and
Uh-huh.
it basically tells the coder the position of the robot, like the roll pitch, stuff like that, so it can line itself up with the goal or whatever. This is the Ethernet port. This connects to the router, like I mentioned earlier, and then these USB ports, they can be used for cameras, stuff like that. This Type B port is used to actually program the RoboRIO.
So that's where Ethan plugs himself in every time.
Yeah, that's where Ethan plugs it in to upload the codes. And then
Right.
this right here is the ports that control the CAN information.
Hey, which port does Ethan plug into?
This is called what's a Type B port. He basically
Oh, okay.
hooks up his laptop to this port right here, and he can upload whatever code he wants. Because somewhere on here there's a micro SD port, which just stores all the code on it. One of the most important things about the RoboRIO, though, is the reset button. If there's like a glitch in the code and the motors are going all crazy, and it's not something dangerous where you would have to press the breaker button, you can just press the reset button and it'll just restart the code.
Like if the motors just keep running, but they're not like doing anything bad, they're just running and they won't stop.
Yeah, it's just for like minor glitches in the code and it just restarts the thing. The big light that I showed earlier, that goes into this port right here. The positive side button.
ERSL.
Yep. That goes directly to the RoboRIO. You don't have to hook it up to the PDP or anything like that. This is very expensive. This board right here will cost about $400 before shipping and stuff like that. So you don't want to break it.
Don't break it, guys. It's expensive. Is
So
it?
that's something we
Is
would
it?
basically move around every year to a different robot.
What's up?
That's what we would basically reuse every year.
Yeah, this is one of the things we would reuse every year. So if you're having like trouble like controlling a robot or the code's messed up, this is the thing that the problem is with. And then there's like these other ports that are for specialty
Sorry.
stuff. I can't really read that, but I think it says relays, analog in. So analog devices would go here. The what is this, I/O ports would be here, and that's just fancy stuff with it. We probably won't ever really use
Right.
the router. So the white box on the robot is what's called the router. Um, it allows you to control a robot wirelessly. It allows you to connect to the field, so you can actually compute. We use Ethernet just because it's more reliable and it's right there next to all the other stuff. So there isn't really much
Might
point
as
in.
well.
Yeah, this is what connects like the joysticks and stuff from the computer to the actual robot. So if your robot just stops moving, you can't control it wirelessly at all. It may be something wrong with the router. Um, on our robot, we have a specialty Ethernet cable that
Mm-hmm.
basically branches out the power lines in order so we can just power it with one cable instead of using the power port right here, which is pretty nice.
It does sound very nice.
Yeah. And then the other Ethernet ports we can use to connect to like the limelight, so we can control that and send data through it. Um, but Ethan recently bought a switch, which basically connects to the router. It takes the signal through Ethernet and allows you to put like 6 ports on it. So instead of just being able to connect the limelight, we can connect 5 other things through Ethernet to the router. Let's see. So the base port would just connect to the router, and you can connect to the router through the network that Ethan set up. And each of these additional ports can be used for limelights, cameras, stuff like that. Um, these routers, the one we have runs off 12 volts. I've seen them as low as 5 volts. I've seen them as high as 15 volts. In between 1 and 2 amps of current. All right. The main safety feature of
Oh
this.
my god, guys.
What's up?
Said, oh my god, guys, it's the breaker.
The one thing you should retain from this session is the breaker. I mean, anything bad goes off, you want to press that red button. It'll pop this switch out, and it'll disconnect the whole thing from the battery, and it won't have any power.
Okay.
So this is basically same. It's the similar to the breaker in your house, except the breakers in your wall outlets, I think, go up to 15 amps. So to put that in perspective on how much power this robot takes, your house breaker pops at 15 amps, and our breaker on the robot pops at 120 amps.
Damn.
So you can start to see where things can get a little dangerous, right?
Just a little bit.
I don't know if you've been shocked by the outlet at your house, but not fun.
Knife it. No, I'm sorry. Never mind.
Um, Obviously, according to FRC, it needs to be easily accessible by everyone,
Rightfully so.
and everyone needs to know where it's at in case something bad happens.
That could 100% be a judge question. Just, hey, so where's the breaker on your robot? Just asking a random person.
Yeah.
Ours is right in front of the battery, right on the backside of the indexer.
Mm-hmm.
There's the question. If you don't answer it, no electrical for you.
Going back to earlier, the breakers on the PDP, 99% of the time, they'll cover any shortages that happen. But get enough current on the wrong day, I guess, those breakers can weld to each other since they're so small.
Right.
And that's just going to short circuit everything. And then you would want to pop this breaker manually. So it could happen anytime. Just
Scary.
yeah. So this is a what's called a manual reset breaker. So once it pops, you have to manually push this lever back in order to.
Right.
The ones on the PDP, those are a little bit different. They're automatic reset. So the robot signal light,
I knew it.
it's also referred to BFL or big. I mean what? This is very important. Um,
That's funny.
if when it's off, your robot's supposed to shut down, but basically on this light, you want to short the two outer terminals together. The middles be ground, and the left will be where the positive voltage goes in. Um,
Okay.
when the robot when the robot's on, it's solid, and when it's on and enabled, which means that the driver can move it around and stuff,
Mm-hmm.
it'll be blinking. So it's just a simple signal that allows FRC people to quickly recognize what the actual robot is doing. And back in Guilford, our light unplugged from the
Right.
RoboRIO, and it was just off the whole round. But thankfully, the FRC people didn't stop the whole match.
Penalize. Yeah.
We yeah, and we just had to get inspected again just to make sure it was all right.
Thank goodness for that. We have enough problems.
Yeah. So a voltage regulator module, or referred to as VRM. Basically, this takes like the high voltage from the PDP, so I think around 16 volts or 12 volts. It gets inputted in these two terminals here in devices that need a lower voltage or lower current would be connected to here because um, on the PDP, the main motors and stuff, that's runs around 16 volts, I think, and a lot of small stuff like the some of the pneumatic stuff actually runs on 12 volts, and this is just a little black box that steps down the voltage. Um, and this is where the power for the router would go to, and so our router runs off 12 volts, so it'd be connected on one of these ports right here. So with motors, there's two main different types of motors. There's brushless and brushed. You don't really need to know like the makeup of them, but basically brushless is a newer type and it works a little bit differently. So we use brushless, and with brushless we have those spark maxes which hook up to them and
Mhm.
allow you to control them through the code and stuff like that. Because if you were to hook these motors up directly to power without a spark max, the controller, um, it'll just uh, not work, and voltage slash current's high enough, it'll just catch on fire.
Bro, that's not good.
Sounds fun.
Yeah, so if you see,
That's when we hit the breaker, right?
that's when you tell whoever's connecting the motor directly to the power to stop. Because those Neos, each of them are $50 a piece.
Didn't we burn one of those?
Yeah, we did.
Two of them?
That that wasn't because of the controller though. I think Ethan was trying to
I know we lost a motor because of the limelight.
the limelight.
Yeah.
Glitching out point
Apparently,
blank.
yeah. Apparently, if it doesn't see the limelight, like the where it's supposed to lock onto,
Mm-hmm.
because the way he has it is that it's locking on the same time as it's like revving it up.
Yeah.
But if it doesn't have a thing, it'll just continue revving and going and going and going,
Yeah.
and it'll just burn the motor.
Yeah, Ethan needs to fix that in the code.
Mm-hmm.
So the motor we use is basically in the top right. It has um 3 different main cables coming, or 4 main cables coming out. The red is just power from the Spark Max. Black is the neutral ground from the Spark Max. The white, I believe, is for the third phase, or stuff you don't really need to worry about. And the shrouding around the it's basically like a set of 6 data cables that goes directly to the Spark Max. The older type, the brushed DC motor, it only has power and ground. And to control the speed, you would just change the voltage hooked up to it. With these brushed motors, they have their own motor controller, which usually isn't really necessary. And it's a lot simpler than the Spark Maxes, which we have.
Right.
But the thing with the brushed DC motors, what makes them good about them is they're cheap. Pretty much anyone can hook them up. And the code for them is a lot simpler than the
Neos.
Neos, yeah. With the Neos though, you can control them a lot more precisely. You do have to connect them up to the Spark Maxes, and it's a little bit more difficult of coding. But as you can see, they're a lot smaller too, so they're a lot easier to mount, and they save a lot of space and weight. Brushless motors like the Neo, more powerful, they last longer, and with the Spark Max controlling all the voltages and stuff, they're a lot more power efficient. And the benefits of a brush motor is they're one of the older types of motors, so they've been really refined, and there's pre-existing documentation on them.
Good.
So the motor controller you want to use depends on the type of motor, like I mentioned earlier. So with the Neos, we use a Spark Max, but with the brushed motors that we were given, and I think it was in the kit of parts, you would use this motor controller, which is a lot simpler. It's just best to look in the documentation of the motor you're using to figure out what type of motor controller you need. And if there's like a specific motor that's glitching out due to code or something, this red button on the Spark Max is actually the reset. So they'll reset the code that's within the microprocessor within this. That's probably main stuff you need to know. So this side of the Spark Max will hook up directly to the PDP for power, and these 3 wires will go to the Neo, and the data ports above these wires, and that'll also go to the Neo. So for wires, there's many different sizes. There's 4 gauge, there's 12 gauge, there's 18 gauge. This just stands for American wire gauge, because for some reason America decided to make their wire gauges different than everyone else, believe it or not. And inside wires, the actual conductor part, there's 2 different types. There's what's called stranded wire, which is basically a bunch of lines of wire woven together, and there's what's called solid core. Solid core is basically just one long metal conductor throughout the whole wire. The advantages of stranded core wire is that it lasts longer if it's going to be moving around a lot, bending a lot. Stranded core wire lasts a lot longer. Stranded core I believe, can handle higher amounts of current, and but with solid core wire, that's really good for if the wire is um, mounted to where it doesn't move at all, and you need high speed data transmission. The main size we use is 12 gauge, um, but the motors and stuff, I think they use 8 gauge, which is a little bit thicker. So the
Does the
yeah.
does the number on it actually represent anything like width or something like that?
So the number for the gauge represents the diameter of the wire, and the lower the number is, the thicker the wire is.
Okay.
Um, some two different types of wires for transferring information is, I talked about it a little bit earlier, it's called PWM and CAN. PWM's pulse width modulation. Basically, you hook up each individual device you're communicating to directly to the RIO, and you can control them individually. The downside of this is you're going to need a bunch of wires. It can get really messy, and the RIO has so many PWM ports, so if you run out, you're basically SOL. For CAN, though, basically 2 ends go into the RIO, and then each motor, each device gets connected on top of the other one. So you can have like an infinite loop of CAN and then just terminate it at the PDP. The advantages of this is there's a lot less wires. You only need 2 long wires. It's a lot easier to manage the cables and stuff like that. The downside, though, is it's a little bit more difficult to code. And if there's one break in the system, all your stuff will not be able to communicate with. So that's all I have. Is there any other questions you guys have? Least favorite wire is probably these PWM wires, because these connectors, they're called DuPont connectors. They're so annoying to crimp, solder, stuff like that, and they're just not that good.
All right.
So going back to the basic circuit that's pretty much on every FRC robot, you can start to see that it's a lot less complicated than it looks in real life. So like you said, the breaker goes in between power of the battery. The Ethernet port goes into the Ethernet port of the router. The RSL light goes into the port labeled RSL on the RIO. And motors go to motor controllers, it just gets powered. That's basically like a basic overview. Just so you know if something goes wrong, you know a little bit about the circuit on the robot and what to do.